Hello everybody. Today I'm going to teach you how to make a .io game using WebRTC. So a .io game is a really cool opportunity because you have the ability to connect as many users as possible, since the only prerequisite needed to play is a device capable of running a web browser. Now I've looked for quite a while on tutorials about how to make these .io games utilizing WebRTC and a server-client architecture, but all the tutorials I found were either really difficult to follow or really hard to reproduce their examples. So in this tutorial, I'm going to provide full working code and give you a high-level overview of why WebRTC is used and is really good to program .io games in. And I'm going to hit the big points in my code that I think you really need to understand. So first up, some background. So at its core, a .io game is just an online multiplayer game that utilizes a server as the computer that runs all the game code and the simulation and relays all the information back to clients or the players. And then they can communicate and see each other moving in the world through the server. So there are two main communication methods that can be used for the servers to connect to the clients. And these are the TCP protocol, or set of rules, and the UDP protocol. Now the TCP protocol is a reliable, ordered form of messaging over the internet, which means that messages will be held up until all the messages are received and in the correct order. Now this is pretty great for watching stuff like movies on YouTube, where you want all the frames and all the audio. But in online games, you get really high latency because newer packets are being held up by older messages that have to be resent if they were dropped somehow. Now UDP is the opposite. It's unreliable and unordered, which means that the most recent packet received is the one that can be instantly used by the program. And this is best for real-time online games because you're always going to get the most recent update. Now there's one huge caveat with programming real-time online games in web browsers, and that is they are not allowed to send arbitrary UDP messages. If there's no way to use UDP in the browser, are .io games even possible? Luckily, there's one more protocol that web browsers support, and this is of course WebRTC. So WebRTC provides a quite complicated, I gotta admit, way to connect users together in an encrypted fashion, and then you're allowed to send unreliable UDP messages. WebRTC was historically used only peer-to-peer, like in Google Meets, Discord, or Skype, to send like video calls and text messages between each other. But now what we're going to try to do is utilize WebRTC on a server side to connect a bunch of client browsers to all be able to play a game together. And to do this, we'll use the wonderful library written in the programming language Go called Pion, which is a full implementation of WebRTC so that we can communicate with browsers. Alright, so for last, but certainly not least, we have the code. Now I was thinking for quite a while about how to do this, because I've seen a lot of tutorials that will go through every line of code as they write it with you. And I don't know about you, but I can never get through those. They're too boring for me, or there's parts that I already know how to do. So since this tutorial is kind of a high-level overview anyway, and I'm going to provide you with all the code in GitHub, I'll go ahead and just hit the main points so you can see how I've structured the code for the game to work. So for our code here, we have a main.go file, an index.html file, and a game.js file. So the job of the main.go file is to be a web server and serve all the clients the web page, which will be our game, and to be a WebRTC client through this echo function here. Now the big thing I need to show you all about the WebRTC client is that I went ahead and made two data channels. One is a unreliable and ordered data channel because it's really nice to be able to get unreliable messages so you always get the most recent one, but you don't need to handle the older messages. So the ordered flag here right there will make it so that the client will drop any old messages, which is a really nice feature that WebRTC comes with built in. And then I also have a reliable channel. Now what this will be used for is anytime you don't want it to be a chance that a player receives something. So like in Minecraft, if a player places a block or a new player joins and everyone needs to know what their name is, you can send that through the TCP channel. I'll also use the TCP channel for player controls. And our index.html here just communicates to connect via WebRTC with our main.go server. And last but not least, we have game.js, and its responsibility is to draw the screen and handle player controls here. So every time a player controls, you'll see it does the TCP channel.send. Alright, so next up, we just have to run our main.exe, which is the built Go server we programmed. And what this program will do is wait for clients to request the web page. So we'll go ahead and do that through localhost. And having two localhost tabs like this will simulate having two players, but one of these would probably be across the internet in real life situation. And the first thing these two clients do is send back to the server their session description protocol, which is this long string of stuff here. And at its core, a session description protocol is a list of IP addresses that the server can use to send the client updates. So this little thing right here. So now that we're all connected, each client is connected to the Go server. If we use the controls, we can send our TCP control messages, and the server will relay all that information via the unreliable data channel. So here we go. So now that you see my yellow player, that's the one I'm moving on the left, and the little pink box is moving on the right too, across the internet. We can do the same thing with the little right one here. And there we are. A very simple networked example. So to further this, you can, obviously add in your own gameplay, so it's not just two boxes moving around, and decide what needs to be synced in what way. So some updates you'll want the most real-time visual of them, and you'll use the unreliable data channel, like here, the player movement. I only want the most recent movement, so I'm sending all those updates via the unreliable data channel. But some updates you'll want TCP, like if a new player joins and you want to get their player name, you can use the TCP channel to relay that to all the clients. Alright, so there's my little demonstration of two players moving synchronously in a server-client WebRTC game. Just remember to use that unreliable data channel for sending all the updates that need to be received as fast as possible to the clients, and then use the TCP channel for anything like controls or like blocks placed in Minecraft, anything that all the clients need to receive. And I know I didn't go too deeply into all the internals of WebRTC, and I kind of skimmed over a lot of the really confusing parts like encryption and handshakes and stuff like that. So definitely go check out Pion, check out their Slack and GitHub. You can learn a lot over there, and it's a really nice, welcoming, helpful community. So I hope you all found this helpful and can build something really cool with it. Alright, thanks so much for watching, and happy coding.